Hey, welcome back to Mr. PF's with PreCal. This is Unit 1, Topic 1, Lesson 1, and we're going to start off by doing a warm-up on two functions that you should have done back in Algebra 2. So this is a quadratic function. The equation to this is simply x squared, or y equals x squared. That's the parent function of quadratics, assuming that these are both going up infinitely. Transformation here is that if the vertex used to be at 0, 0, and now the vertex is at 3, negative 2, so it's right 3 and down 2. And the equation, if you write it in, the easiest way to be to write it in the transformation form, so that would be x minus 3 squared and then minus 2. So the minus 3, remember, it's always the opposite whenever it's on the inside of something, so it means it's going actually to the right 3. And then on the outside, that's your h, that's your k. Your k determines if it goes up or down, and that's minus 2. So y equals x minus 3 squared minus 2. All right, so this video is basically going to be a review of the 12 basic functions that you should have learned back in Algebra 1 and Algebra 2. Quick review. Domain is simply a list of all the possible x values. It's all your inputs, whereas range is all of your outputs, which is your y values. Asymptotes are those imaginary lines in which a function does not ever reach, so it gets closer and closer and closer for infinity, but never quite reaches it. Even functions are functions that reflect over the y-axis, and odd functions are functions that reflect over the origins, and you'll see a couple examples of that in this video. End behavior just basically specifies how the function behaves on both ends of the domain, so whether or not it's going up infinitely, down infinitely, or towards an asymptote. Continuous functions are functions that have no breaks in them. So basically, you can draw the function without picking up your pencil. Would be the easiest way of explaining that. Continuous, there's no stops, there's no breaks, there's no two pieces. It's all one part. The new word here is bounded. So bounded just means that the entire function is either above or below a specific horizontal imaginary line, kind of like an asymptote. So this is called bounded below because the entire function is bounded by this dotted line, so the entire function is above that. Whereas bounded above means that at the top, it stops at the top, so then it comes back down because it's bounded by that horizontal line, that imaginary horizontal line. Okay, so starting off, the most basic function we have here is a linear function. This is linear. The domain is all real numbers because it's going left and right infinitely. The range is also all real numbers because it goes up and down infinitely. This is continuous because you can draw it with one line. It does not have any asymptotes. The end behavior, as x is going towards the right, which is towards positive infinity, the height is going also up towards and positive infinity. As x goes to the left, that would be towards negative infinity. The f of x goes down towards negative infinity. So this is linear. This is an odd function. Not all linear functions are odd functions, but you'll notice that this one, every point has another point on the opposite side of the origin in the exact opposite side. This is not bounded by above or below because it's going up infinitely and it's going down infinitely. Our second function you should have learned about back in Algebra 1 was quadratics, like this. This is quadratic. Its domain is all real numbers. It goes left and right infinitely. Its range is everything that's above 0. Above or equal to. This is continuous. You can draw it all in one line. Its asymptotes, so it does not have any asymptotes. It is actually going to reach this point, so there's no dotted line that it's going to go closer and closer and closer to that it's never going to reach. As you go towards the right, it's going up towards infinity. As you go to the left, it's going also up towards infinity. I almost messed that up. So this equation is just the basic function. This is just y equals x, and this is y equals x squared. This is an even function, and the reason why it's an even function is because it's a perfect reflection over the y-axis, and it's bounded below. It's bounded below because it has a horizontal line that entire function is bounded above it, so it's bounded below because it can't go below that line. That's the way I look at it. This is a exponential function, so you should have also learned this in Algebra 1. Domain is all real numbers. It goes left and right infinitely. Range is everything above 0. This is continuous. You can draw it all in one continuous line. It does have an asymptote, so it has an asymptote right here at y equals 0. Exponential functions you should have learned have horizontal asymptotes, and logarithmic functions have vertical asymptotes. That's what makes them inverses of each other. The end behavior as you go closer to the right is the further you go to the right on this function, the further you go up towards infinity, and the further you go to the left, the closer and closer you get towards 0. So that's that asymptote that I was talking about. The further you go left, it's going to keep going down infinitely if you go left, but it's never going to reach it. So this is bounded below. And the reason why is because it has that horizontal asymptote, it's never going to go below that. The entire function is above it. This is neither even or odd because it's not a reflection over the y-axis, nor is it a reflection over the origin. All right, the next function is a cubic function. So this is y equals a to the x power. This is y equals x cubed. This is continuous. Its domain is all real numbers. Its range is also all real numbers because it goes up and down infinitely and left and right infinitely. As x goes towards the right, it's going up towards infinity, and as you go to the left, it's going down towards infinity. It does not have any asymptotes. All right, so the next function we have, this is a square root function, which is the inverse of a squared function. So domain in this case would be anything that's greater than or equal to 0 because the entire function starts here on the x-axis and goes to the right. The height of the function is everything above 0 as well because the lowest it can possibly go is 0, which means it's bounded below. It's neither, and it does not have any asymptotes. End behavior, as you go further to the right, it goes up towards infinity, and the further you go to the left, the closer it gets to 0, the further you get to the left. This is a logarithmic function, so you're starting now into Algebra 2 functions that you should have learned. The domain in this case is anything that's greater than or equal to 0. This is the furthest you'll ever get. Actually, it's not or equal to, sorry. It's just greater than 0 because you're never going to reach an x of 0 because it has that vertical asymptote. At least it looks like it's right at 0. I'm going to have to assume that. And the range is going to be all real numbers. So it goes down infinitely and it goes up infinitely. This is neither odd nor even. It is not bounded above or below because it goes up and down infinitely. So when you have a range of all real numbers, then basically it's not bounded. So your range kind of tells you whether or not it's bounded or not. This is continuous. It does have an asymptote at x equals 0. Remember, it's a vertical when it's a logarithmic function. The further you go to the right, the further it goes up towards infinity, and the further you go to the left, the closer it gets to negative infinity. All right, so the next function, this is cubic root. It looks very similar to square root, but it has on both sides because remember square roots, cubic roots and cubic root of a negative does make sense because a negative times a negative times a negative is a negative, but square root of a negative is imaginary. So that's the reason why this has both sides and the other one does not. The domain is all real numbers, goes left and right infinitely. It also goes up and down infinitely. It is continuous. It doesn't break. It does not have any asymptotes. The further you go to the right, the further it goes up towards infinity. And the further you go to the left, the further it goes down towards infinity. And this is y equals cubic root of x. These are all basically, this is not bounded because it goes up and down infinitely. Remember that? So there is no bounding above or below. This is an odd function because every point over here has an equal and opposite point on the other side of the origin. Next we have absolute value. The domain is all real numbers. The range is everything above or equal to 0. So this is the lowest it ever gets, which means it is bounded below. It does not have any asymptotes. It does not have any dotted lines that it goes closer and closer and never reaches because it will actually reach this point. This is an even function because it's a perfect reflection over the y-axis. X, as you further to the right, the further it goes up. The further you go to the left, the further it goes up as well. All right, and I think that brings us, okay, we have 4 more. So next we have a rational function. This rational function has a domain of all real numbers. However, I'm going to write this a little bit differently. X is a set of all real numbers in which x cannot be 0. And the range is the same thing. So y is a set of all real numbers in which y cannot be 0 as well. So the reason why is because there's an asymptote in the middle. There's both an x and a y asymptote. There's two asymptotes here, x equals 0 and y equals 0. End behavior, as x goes further to the right, the closer it gets to 0. As that's this piece right here, closer it gets to 0 to a height of 0, and the further you go to the left, also the closer it gets to 0, because you'll see this piece, the further you go to the left, the closer it gets to this horizontal asymptote. So this is not bounded because the range is all real numbers, so it's not bounded above or below. This is a odd function. It is an odd function because every point here has an equal point on the other side of the origin. All right, so this is a trigonometric. To be more precise, this looks, although it could be transformed, of course, all sine and cosines can be transformed, but since it's starting at the midline, then you know it's a sine function, whereas cosines functions, unless there's a transformation involved, a left and right transformation that is, typically start at the maximum or minimum. Domain, all real numbers. All numbers to the left and right have an answer. The range, it looks like it has a height of 1 and -1, so the range y is between -1 and 1. This is an odd function because it's a perfect reflection over the origin. It is bounded above and below. It does have a highest point and a lowest point, so it has a maximum and a minimum, so it's bounded on both sides. The further x you go to the right, the closer, okay, so this end behavior actually will change, so it's going to go up and down, so it's end behavior, and same with the left-hand side. So this end behavior actually changes over time. This is continuous. It does not have any asymptotes, even though I drew dotted lines. It actually does hit those. I was just showing that to show the range. And the last two functions. So this is a cosine function. So it's basically the exact same things as I just said. Only the difference is it's starting at the maximum. It is an even function. That's really the only main difference here. Everything else is pretty much the same. It's an even function because it's a perfect reflection over the y-axis. It's not an odd function like sine functions are. And the last but not least, we have ourselves a step function, and the domain's a little bit tricky here. The way I would write it, I would say x is a set of all real numbers in which x cannot be a integer. The reason why is because it has breaks in between each one of these steps, and you look 1, 2, 2 does not have an answer. There's a break, there's a jump, I should say. So it's hard to tell if those are open circles or closed circles. I guess I should not assume. So I guess possibly the domain is all real numbers. It depends upon whether or not these are open or closed. The range in this case will be all whole numbers. So y is a set of all whole numbers, of all integers, sorry, set of all integers. So it can be 1, 2, 3, 4, 5. It can also be -1, -2, -3, -4. So it's a set of all integers. End behavior, the further I go to the right, the further it goes up towards infinity. The further I go to the left, it goes down towards infinity. And this is an odd function, it looks like. No, it's not. It's not an odd function. This is neither. It is not bounded because it goes up infinitely and down infinitely. And last but not least, this is one of the few this is like the only one that we've done that's been discontinuous, meaning that you cannot draw this without picking up your pencil. No asymptotes as well. All right, thanks again. That will be the end. So that we talked about all 12 of the basic parent functions, which we'll be exploring more in the future videos. Thanks again for watching. Have a great day.